Section 9. Section 9, we discuss exponential modeling. When absolute change is the same for a time period, the mathematical model is linear, y equals mx plus b, where something only changes by an amount. When relative change is the same for a time period, the mathematical model is exponential. The amount equals the starting value times the growth factor to a time period. The growth factor can be found using the formula. Growth factor equals 1 plus the percent change. The percent change is relative change, new minus old over old. Here's an example. According to the 2010 United States Census, the population of one town has 68,320 people, roughly 12% increase from 61,000 in the year 2000. Create a model that correctly represents this population change per decade. So the initial value, the starting value, is the first year that we have, the year 2000. The value was 61,000. We have a 12% change, so it's 12% increase, so that's 112%. Here's our model. We have our starting value times the growth factor to the time. Population of a certain species of frog grows 18.6% each year. Suppose 39 frogs are released into a pond. Construct an exponential model to predict the population frogs. So we see our growth, it's changing by a percentage. The initial value is 39, and so we can set up our model. We're supposed to use our model to predict what happens after 9 years. So we plug in 9 as the exponent, and we find 181. The half-life of a radioactive substance is 1 day, meaning that every half of the substance has decayed. Suppose that you have 780 grams of a substance. So we have a percent change, it decreases by 50%. The initial amount was 780 grams. We have our exponential model. If we want to find it after 5 days, like part B asks for us, we can plug in the number 5, and we find it's roughly 24 grams. A certain vehicle loses 10.4% of its value each year. If the vehicle has an initial value of $25,800, construct a model that represents the value of the vehicle after a certain number of years. Use your model to compute the value of the vehicle at the end of the 6 years. So we have our change by percent. It's changing, it's decreasing 10.4%. The initial amount was $25,800. And so now we have our exponential model. They want it after 6 years, so we plug in 6. And now we have the new value of the vehicle. Atmospheric pressure decreases by 11% for every 1,000 meters you climb. The pressure at sea level is 1,013 millibars, a unit of pressure. Construct an exponential model to represent the atmospheric pressure at a given altitude in thousands of meters. Use your model to determine the atmospheric pressure at an altitude of 5,200 meters. So we know it's decreasing by 11%. We know the starting value. We can construct our exponential model. The issue with this problem is it's changing every 1,000 meters. So I have to understand, how does this value change? I can't just plug in 5,200. So I find that it's changing 5.2 times. Plug that in our model. And now we have the new pressure. Compound interest. When money is invested earning compound interest, it earns not only on the principal but also on the interest itself. The compound interest would be balance equals the principal times 1 plus the rate to the time. Compound interest model has the same growth factor every time period. This is exponential. And then we see the same formula on our formula sheet. Susie invests $1,200 in an accounting earning 3.6% interest compounds annually. If she makes no additional deposit or withdrawals, how much will be in the account after 12 years? So we have the initial amount, we have the rate, we have the time. We can plug this in our formula. And so we find the ending balance. You borrow $2,300 at 5.1% compounded weekly for tuition. While you do not have to make payments for the next 5 years that you are in school, the interest is compounding. What is your loan balance after the 5-year grace period? We have the initial amount, we have the rate, we have the number of times it's compounding, 52, since it's weekly, and we have the number of years. We have our formula. We can make our model. So we have the starting value, the compounding, the time, and we have the ending value. Rule of 70 for doubling time. An exponential function with a constant growth rate of p doubles approximately 70 divided by p. For example, if the growth rate of a single deposit in the bank is 3.5%, the deposit will double 70 divided by 3.5 equals 20 years. Juanita has the opportunity to put $3,400 investment with the APR of 7%. How long will it take her to invest to quadruple? Express your answer rounded to the nearest tenth. So we're going to use rule of 70 for this. So we have 70 divided by the percent, roughly 10 years to double. So it would take 20 years to actually quadruple, which is what this particular question asked.